So, number one says find the x and y-intercepts of this line. We used to graph lines in y equals mx plus b, and we would see where it crosses the x-axis, where it crosses the y-axis, or you could do it algebraically. And to find the x-intercept, we simply set y equal to 0 and solve. So instead of y equals 2x minus 4, you'd have 0 equals 2x minus 4. And if you solved for x, you could put the equal 0 on this side instead. You'd go plus 4, you'd have 2x equals 4, which means that x equals 2 when you divide both sides by 2. And that would tell you that the line crosses the x-axis at 2. To find the y-intercept, you set x equal to 0. So instead of saying y equals 2x minus 4, you would say y equals 2 times 0 minus 4. So let's write that down. Y equals 2 times 0 minus 4. So the answer there would be 2 times 0 is 0, and 0 minus 4 is negative 4. So the y-intercept would be at negative 4. So my point here is, guys, we are able to identify where this line will cross the x-axis at the value of 2 and the y-axis at the value of negative 4. We did that algebraically. We didn't have to graph with y equals mx plus b. Later on today's lesson, I want to give you a quadratic formula, and I want to tell you where does it cross the x-axis. You do not have to graph the parabola in order to see where it crosses the x-axis. All you have to do is set y equal to 0 and solve. The next part of the class opener, simplify the following radical values. The square root of 24, it's not a nice perfect square number. So we need to remember this. If you don't have a perfect square number, rewrite it with multiplication to get a perfect square number, right? The square root of 25 is 5. The square root of 49 is 7. The square root of 4 is 2. If you have a perfect square number, it's a nice perfect answer. But if you don't have a perfect square number, you want to rewrite it with multiplication to get a perfect square number. And you want to go with the highest perfect square number possible. If you completely forgot what a perfect square number is, I might as well jot down a perfect square number list right here. It's 4 because 2 times 2 is 4. 3 times 3 is 9. 4 times 4 is 16. 25. 36. 49. 64, 81, 100, and so on, right? Those are all perfect square numbers. So 24 is none of these. You want to rewrite 24 with multiplication so you could get one of these. What would you rewrite it as? 4 times 6. So if you rewrite it as 4 times 6 and then split that root, you will be able to do the square root of 4, which is 2, and the square root of 6, you can't really do it and you can't break it down any further, so you just leave it, right? So we need to be able to simplify square roots, something we've already done in the past. And like I said, you want to use the biggest perfect square number possible. So you could go with 4 times 8 on the square root of 32, but the better option would be to use the bigger perfect square number, 16. Right, 16 times 2. That way when you split it, the square root of 16 is 4, square root of 2 stays square root of 2, and you're done. Any questions? So this is all review right here. Square root of 108. If you think about the biggest perfect square number, it's 36 times 3. That gives you 108. Square root of 36 is 6. The square root of 3 stays square root of 3. So simplifying radicals, simplifying square roots is an important, essential skill when we apply the quadratic formula, which is what we're doing today. Now, today's lesson is on the quadratic formula, and before talking about the quadratic formula, we need to get some certain vocab words down. Let's understand this. All of these words mean the same thing. If I tell you, here's a quadratic equation, find the answers. If I tell you, find the solutions. If I tell you, find the x-intercepts, find the roots. All that means is for you to solve the quadratic equation, right? So when they ask you to find the x-intercepts, how do you find the x-intercepts? You set y equal to 0 and solve, right? So everybody, let's do that. For my x-intercept, let's set y equal to 0. So my equation is not going to say y equals, it's going to say 0 equals x squared plus 4x plus 3. Okay? And you could put the equal 0 on the other side. You don't have to keep it on the left side. Now, how would we solve these a couple of weeks ago? Actually, it was 3 weeks ago. How would we solve these? When we had a quadratic equation set equal to 0, what would we do?
Put parentheses.
We put parentheses, right? The parentheses, the x, and what times what? What times what is the c value that if I combine together is the b value? You guys remember that, right?
3 times 1.
3 times 1, right? Positive 3 times positive 1. So plus 3 plus 1. And then that's what we call factoring. After factoring, what would we do?
Solve. So
you split it and solve, right? The zero product property says if you have something times something equals 0, the first something could be equal to 0. The second something could be equal to 0, right? So your two answers are going to be x equals negative 3 and x equals negative 1. So if I were to graph this parabola, this standard form quadratic trinomial function, how would I graph it? Well, step 1 is to find the vertex. Oh, negative b over 2 times a. And then you plug that into x to find your y value. You find your vertex. You use your pattern or an xy table. Then you could graph it. If you were to graph it, this graph would cross the x-axis at negative 3 and at negative 1. Okay? So you're able to find the x-intercepts without graphing and looking at where it crosses. On the quiz we had last Friday, I asked for the x-intercepts. You had to look at it. You had to graph it and then look at it, and then you state the x-intercepts. You could actually find the x-intercepts by setting y equal to 0 and solving. So once again, finding the x-intercepts, it's the same thing as them asking you for the answers. Same thing as solutions. Same thing as roots. It's all the same thing. So we have tons of examples here. By the way, this one, you should change it to a 1 or else you're not going to be able to do it. But the bottom line is, if you factor, split, and solve, you're going to find answers. And it doesn't matter if they ask you for the roots, for the answers, or for the solutions. It all means the same thing. Now, you don't have to factor, split, and solve. Like, check out this last one right here. This last one, they want us to find the solutions, the answers, the x-intercepts, whatever you want to call it. You could set y equal to 0, right? Let's put this as a 0. Let's rewrite it as x plus 2 squared minus 9. Let's put the equal 0 on this side. And it's technically kind of already factored for us, but what I'm going to do, since there's only one x, is to get x by itself. How would I do that? Adding 9, rewriting x plus 2 squared equals a positive 9. How do I get rid of a square?
The opposite.
What's the opposite of a square? A square root. And remember that when you apply a square root in an equation, you have to put a plus or minus in front of your answer. So the square root of 9 is a plus or minus 3. And what do we have left? We have an x plus 2, no more squared, equals that plus or minus 3. My final step would be to subtract 2 and subtract 2. But the problem is, you can't just subtract 2 from a plus or minus 3 because that's really two different numbers, a positive 3 and a negative 3. So the best thing to do is to rewrite your answer. Let me rewrite it right here. X equals, the negative 2 goes first, and then the plus or minus 3 goes second. Now, why do I do that? Because plus or minus 3 really means negative 2 plus 3 and also negative 2 minus 3. And it's going to produce two answers, a 1 and a negative 5. Those are your two answers to that equation. Now, that equation was in vertex form, right? We could all clearly see that the vertex is negative 2, negative 9. That's a vertex. I could have used the pattern 1, 1, 2, 4, 3, 9. If I were to have graphed this vertex form equation, my answers tell me that they cross the x-axis, that the parabola actually crosses the x-axis at positive 1 and negative 5. So it's all related, guys. Everything we've done is related. Now the problem is, what if you can't solve it by applying a square root? What if you cannot factor it, right? Like factor, split, and solve. What if you can't do that? Then that's when we have to memorize the quadratic formula. Okay, so that's what I explained right here. What if they ask you to solve something that's simply not factorable, like this guy? Like we might be thinking, oh, okay, I could factor that. And you put parentheses equals 0. But when you start thinking about it, what times what is negative 6 that if you add together is negative 7? It doesn't work. It's just not factorable. So if it's not factorable, then maybe the parabola does not cross the x-axis at all. Or maybe it does cross, but you're at irrational decimal values, crazy decimal values, right? In other words, you have to memorize the quadratic formula because a lot of times factoring doesn't work. Most of the time factoring doesn't work. But the quadratic formula will always work. So memorize this. X equals negative b plus or minus the square root of b squared minus 4 times A times C, all divided by 2 times A. That's your homework for tonight, memorizing that quadratic formula. All right, so negative B plus or minus square root of B squared minus 4AC divided by 2A. Memorize it. That way you could just say it like I did without even thinking about it. Even in Spanish. Negativo B más menos raíz cuadrada de B cuadrado menos 4AC dividido por 2A. I don't even think about it. It just comes out, right? De nada. So all you have to do is memorize this formula and, of course, know how to use the formula, and then you'll be able to find answers. So let me show you. Up here, we could not factor it. We couldn't do it. Couldn't do it. So we're stuck. Oh, I guess I can't solve it. But the quadratic formula will let you solve it. Check this out. On top of memorizing, you need to know how to apply it. And when I apply it, I'll tell you this. You need to replace the letters with parentheses. So x equals negative b, let's put negative parentheses, plus or minus the square root of, let's put parentheses squared, that's a b squared, minus 4 times a times c, minus 4 times parentheses, all divided by 2 times parentheses. You need to do this on every single question when I ask you to apply the quadratic formula. You have to set it up exactly like this with blank spots. If you don't do this, you're going to mess up. Okay, you have to do this. Now let's identify our A, B, and C value. What's our A value? 1. What's our B value? Negative 7. What's our C value? Negative 6. Let's plug in those values where the parentheses are at. So negative B, that's negative 7, or negative 7, and then B squared, that's negative 7 squared. 4 times A times C divided by 2 times A. Is everybody with me? Okay, so that's how you plug in. And now let's get you started on how to simplify this complicated looking math. You simplify it by starting with your discriminant value. What the heck, discriminant? Is this guy racist or what? No, discriminant is the value inside the square root. It's a new vocab word that you need to learn today. Discriminant is the value inside the square root. It's the b squared minus 4ac. All right, let me underline it here. This value, the b squared minus 4ac, that's what we call the discriminant. Okay, and it tells us a lot. But you start with the discriminant value. So let's go to the inside of the square root, and let's start by doing the math there. Help me out, guys. What's negative 7 squared? 49. Okay, so down here, I want to rewrite my square root, but I want to put a 49 instead of the negative 7 squared. All right, and help me out here. You could call this a negative 4 if you want, or you could call it a minus 4. It's totally up to you. I want to go with negative 4 times 1. That's negative 4, and then negative 4 times negative 6. What's negative 4 times negative 6?
20.
Positive 24. So I am going to put plus 24. Is everybody with me? I am working on the discriminant here. And let me just do the rest. The plus or minus is still there. The minus 7 that was over here changes to plus 7. So that's just a regular 7, right? And on the bottom, instead of 2 times 1, what should I write? Just 2, right? But we still need to do the discriminant. What's left? The 49 plus 24. Help me out here, guys. What's 49 plus 24? That's 73. All right? So our answer so far is 7 plus or minus the square root of 73 divided by 2. And ladies and gentlemen, those are our 2 answers that actually represent the x-intercept of this parabola, the 2 different x-intercept values. So this parabola really does cross the x-axis at 2 places. Now you're thinking, how do you know that? Well, 73, it's not a nice number, but it's irrational. I will get a decimal number for the square root of 73, right? So if your discriminant is positive, you're going to get 2 answers, because when you add that number, if it's an ugly decimal or a nice number, whether you add it or subtract it, you're going to get 2 separate answers. So if your discriminant is positive, you're going to get 2 answers. If your discriminant is negative, you can't do the square root of a negative. That means that you have no solution. If your discriminant is 0, it doesn't matter if you add or subtract 0, you only get 1 answer. We'll get to that in a little while. But right now, that's your answer. There's nothing else you could do. What should you try to do? You should try to look at the square root of 73 and try to simplify it. But we can't. We cannot simplify the square root of 73. It's like you can't break it down with multiplication to be 4 times something or 9 times something or 16. It just doesn't work. 73 is prime, right? So that's as far as you could take that answer, and that's it. And on the multiple choice on the final exam, you're going to have tons of these, and they're going to leave them exactly like this. Even though 73 is actually like a decimal 8.554301 and it's irrational, so you could technically get approximations like, 7 plus 8.5, 7 minus 8.5, divide both of those answers by 2. You'll actually get 2 locations on the x-axis. But this is going to be your answer. That's how it's going to be written on your final exam. So we're going to be practicing using the quadratic formula today on a homework assignment. And we're also going to be practicing using the discriminant to determine if there's one answer, 2 answers, or no real answers. So we're going to have to skip around here, but like here's an example of a parabola or an equation only having one real answer. That one real answer would be x equals -1 because the answers are the x-intercepts. You don't have this on your notes. I just want to give you a visual. Right here, this parabola, how many answers does this parabola have? What are the answers to this parabola? Which, by the way, this is the equation, x equals, or y equals -x squared minus 2x minus 2. That's the graph of this parabola. If I told you to solve it, what would the answers be?
0.
You're telling me that the answer is 0, that the parabola touches right here?
No, it's not.
That means no real answers. So you would say no solution, right? So sometimes you get one answer, like right there, the answer is x equals -1. Sometimes you get no solution. This is an example of no solution. And sometimes you actually graph it, and it does cross at 2 locations. So that would tell you that it actually has 2 real answers, x equals -2 and x equals 0. Okay, so you could use a graphing calculator to solve quadratic equations. Anyway, let's think about the discriminant value, which is the b squared minus 4ac, which is inside the quadratic formula, inside the square root. Now, if you're working on a quadratic formula and the inside of the square root ends up giving you a positive value, it doesn't matter if it's a nice perfect square number or not. If it's greater than 0, if it's positive, you're going to end up with 2 real answers. If your discriminant value is equal to 0, then you're going to have the square root of 0 using the quadratic formula. And when you add or subtract 0, you get the same answer. If your discriminant value is a negative number, the number inside the square root, if it's negative, if it's less than 0, you know you can't do the square root of a negative, which means that it's impossible to do. It's imaginary, which means that it doesn't cross the x-axis, which means that there is no real answers. Okay? So by looking at your discriminant value, if it's positive, you have 2 answers. If it's equal to 0, you're only going to get 1 answer, because it doesn't matter if you add or subtract 0, you get the same answer. And if it's negative, you get no answers because you can't do the square root of a negative. I guess the best way to do this is to take a look at our homework. Okay, so here's the homework, and let's go to the question number 1. And before going to question number 1, you need the quadratic formula. So let's all write it down. X equals -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. Now, you must replace the b, the a, and the c with parentheses. So on number 1, let me rewrite the formula, but without the letters. I want to say it though. -b plus or minus the square root of b squared minus 4 times a times c, all divided by 2 times a. This is the trick to not making mistakes, to rewriting your formula with the parentheses instead of the letters. So now let's identify the b value, which is 2, the a value, which is 1, and the c value, which is -3, and plug them in accordingly. So you have 2 for b, the a value is 1, and the c value is -3. Now, where do we begin all this math? With the discriminant value, the value inside the square root. So when I do 2 squared, what do I get? I get 4. And then when I do -4 times 1, that's -4, and then -4 times -3, that's +12. So I'm going to get a... So I have 4 plus 12. And that is our discriminant value. Let me bring down everything else, plus or minus the -2 out in the front and the 2 on the bottom. So our discriminant value is really 16. So what we really have is -2 plus or minus the square root of 16 divided by 2. Now, because the discriminant is a nice, beautiful 16, you could actually do the square root of 16, and what do we get? We get 4. So what I really have here is a negative 2 plus or minus the nice beautiful number 4 divided by 2. And that plus or minus actually gives us two answers. Let me zoom in here because I'm running out of space. It's going to give us the negative 2 plus 4 divided by 2, and it's also going to give us a negative 2 minus 4 divided by 2. So the negative 2 plus 4, that's really 2 divided by 2, the answer is going to be 1. And on the bottom, negative 2 minus 4, that's really a negative 6 divided by 2, which gives us a negative 3, and that's the other one. So those are our two answers, our two real answers, our two x-intercepts. If I were to have graphed this quadratic trinomial equation, y equals x squared plus 2x minus 3, the parabola, after finding the vertex by doing negative b over 2a, after finding the vertex and after making a table or using the pattern, I would see that it crosses the x-axis at 1 and negative 3. It has two real answers. Now, why does it have two real answers? Because the discriminant value was positive. If it's positive, you're going to get two answers, because if you add a real number and then subtract a real number, it's going to give you two different answers. Now, if your discriminant was 0, ladies and gentlemen, if this 16 was actually 0, the square root of 0 is 0, and it doesn't matter if you add 0 or subtract 0, you're going to get the same exact answer, which in this case would be negative 1, because negative 2 divided by 2 is negative 1. So if your discriminant is 0, that means that there's only one real answer. That means that your parabola would only touch the x-axis at one location if the discriminant is 0. If your discriminant is negative, like if this were a negative 16, you wouldn't be able to do the square root of negative 16, so you wouldn't be able to do the rest of the work. You would get stuck right here. The square root of negative 16 is imaginary, which means that there's no solution, which means that visually the parabola does not cross the x-axis. So the top part is all about practicing the quadratic formula, and when you use the quadratic formula, please use parentheses. This whole top half is all about using the quadratic formula. The bottom half, they just want you to focus in on the discriminant and say whether you have one real answer, two real answers, or no real answers. How many real answers do you have? Well, if your discriminant is positive, you know you're going to end up with two answers. If your discriminant is negative, you can't do the square root of a negative, which means you're going to get no real answers. If your discriminant is 0, you're going to get only one answer. Okay? So let's all take a look at number 16 here. And let's pretend that they asked us to find the actual answers. You could factor, split, and solve, but using the quadratic formula, we'd be doing negative b plus or minus the square root of b squared minus 4 times a times c. I put the discriminant in blue right there, divided by 2 times a. Now on the inside, our a value is 1, our b value is 8, our c value is 16. So I would do b squared, that's 8 squared, and then 4 times a, that's 1, times c, that's 16. And when I do the discriminant value, what is 8 squared, guys? What's 8 squared? 64. Okay, so I really do have a 64 so far. Then how about negative 4 times 1, that's negative 4, and then negative 4 times positive 16, that's negative 64. Now, I could fill out the rest of this quadratic formula. I could put the b value of 8 out here and the a value of 1 down here, which means that if I continued with the quadratic formula, I'd have a plus or minus negative 8 out here and a 2 down there. But what's our discriminant value? 0. Now, what does that mean if our discriminant value is 0? Negative 8 plus or minus the square root of 0 divided by 2. What does it mean if the discriminant is 0? That you're only going to get one answer. Okay? What would that one answer be? Well, the square root of 0 is 0, which means that you'd have a negative 8 plus or minus 0 divided by 2, which it really doesn't matter if you have negative 8 plus 0 divided by 2 or negative 8 minus 0 divided by 2. You're going to get the same answer. Negative 8 divided by 2, which is negative 4. So it doesn't matter if you're adding or subtracting 0, you only get the answer negative 4. Now, on this section, are they telling you find the answers? Are they telling you solve? Are they telling you find the x-intercepts? No. What are they asking you to do? They're just asking how many answers do you actually have? How many answers did we get right here? One. That's all they're asking for. So I want to say one. One real solution. Like if you flip over the paper, they don't show the answer negative 4. We found the answer negative 4. all they ask for is, how many answers do you have? Do you have one real answer? Do you have two real answers? Or you have no solution, no real answers, right? Now, I didn't have to do all of this work. If I just do the discriminant and my discriminant is 0, I know I'm only going to get one answer. If my discriminant is negative, I only get no answers. If my discriminant is positive, it doesn't matter if it's a perfect score number or an ugly number or a prime number. It doesn't matter. If it's positive, you're going to get two answers, right? So that's all they're asking for. Do you have one answer, two answers, or no answers? And you could all determine that with the discriminant. If the discriminant is positive, you get two answers. If the discriminant is negative, you get no answers. If your discriminant is 0, the way we had it right here, you're obviously only going to get one answer because it doesn't matter if you add or subtract 0. It doesn't change anything. So that's what we're doing on this second half. The second half is just practicing the discriminant, b squared minus 4ac. One answer, two answers, or no answers. Up here, you do want to practice the entire quadratic formula. So I'm done with this video. I'll make another video explaining the questions on the homework. I need you guys to start practicing right here on this homework assignment.